Hello, this is Ptharian's Flame, and welcome to my 5th Haskell tutorial. In this video, we'll be going over types, the beginnings of the Haskell type system. So, in the last tutorial, we went over partial application and currying, and in the one before that, we went over functions in general and operators. And so, it seems fitting that the first type we come across is that of a function. So this is what you get from the :t or :type command in GHCI, and you can annotate these in your Haskell source file, as I'll show you later. But let's just say we have the type A to B, where A is whatever the function takes as an argument, and B is whatever the function spits out, whatever the function's output is. So input type, output type. So if I were to write a complete declaration, this would be fun A to B, which would be equivalent to the C version, or C-like version, I guess, be my fun A param1, I guess. Right? This is how you'd write it in a C family style, or general curly bracket style language. Now, how about this? So this is a function. This can actually be interpreted two ways. This is a function that takes one parameter and returns another function that takes one parameter and returns another parameter. This is the whole concept of, or returns a value of C, right? This is the whole concept of partial application and currying that I was talking about in the last tutorial. Or you can just view it as a function of two parameters that returns C. Viewed that way, it's equivalent to C my fun A param1 B param2, right? But viewed the curried way, which it technically always is by default in Haskell. I mean, they're perfectly equivalent as far as Haskell is concerned. There's no real equivalent for that as far as more traditional notation goes. So I guess you'll just kind of have to get used to this. One thing to note, this is an actual valid signature in Haskell as is. A, B, and C don't necessarily have to be types. These are type variables. One thing to note in Haskell is that variables, both on the type level and the value level, are always lowercase if they're non-symbolic. So, in fact, even if they are symbolic, you just have to think about them the right way. So, there are basically four classes of identifiers. You can have a variable, which can either be an alphanumeric variable, which has to begin with a lowercase letter or an underscore, and then can be so lowercase letter or underscore, and can then be followed by any string of alphanumeric characters, underscores, or prime characters, single quotes. We pronounce them prime. Or any symbolic character. And symbolic characters can be composed of a whole bunch of things. You can have... Actually, you can't have parentheses, sorry. But you can have these, and you can have that stuff. I think you can have... Yeah. You can have any of these. If it begins with a colon, it is effectively capitalized. If it doesn't, it's effectively lowercase. So variables are always lowercase, either literally alphanumeric lowercase, and constructors are always capitalized. Again, either literally alphanumerically capitalized or capitalized with a colon if they're symbolic. The colon has to be in front. So that works both on the value level and the type level. Haskell is very consistent that way. So the other thing to note about the very beginnings of the type system that we'll go over more in the next tutorial is that there is partial application. So like we have with functions, we have, parametric polymorphism. So we have my fun equals my fun x, y, right? So this is, I'm applying my fun to the parameters x and y. Or more precisely, I'm applying my fun to x, and then taking that result and applying it to y. This is completely equivalent. Likewise, on the type level, we have my type constructor, type var1, type var2, so we could have a type constructor with any number of type variables after it. And it's written the exact same way on both the type level and the value level. Keep in mind that, although I've said that this is a type constructor, Haskell will actually treat this as a value constructor right now. Although, actually, this file currently wouldn't parse as a valid Haskell program. But value constructors and type constructors live in different namespaces, and you'll learn how to tell apart where they are. But they're effectively independent of one another. You can have a value constructor and a type constructor that are named the exact same thing. You can have a value variable and a type variable that are named the exact same thing. And like values that have types, so I would say a is my fun is of type int to string, right? I could say my type constructor is of type star to star to star. Except I shouldn't be saying is of type here. I should be saying is of kind. Types have kinds the same way values have types. Kinds have sorts, but there's only one sort in existence, and it's called box. This is, it takes a type of kind star and another type of kind star and produces a type of kind star. So my constructor x, if x is of kind star, then we've applied it, right? If y is also kind star, then we've applied that. This works the same way as generics do in Java, C#, etc. Except higher kinded polymorphism also works. And just briefly, I'll go over it more later, but just briefly, it works like this. So just like we can have a function that takes a function as a parameter, we can have higher order functions, like map is of type A to B to list of A to list of B. For all A and B, these are type variables. This is polymorphic over type variables. And we can likewise say that well, I don't know. Let's just come up with a random type foo. Is of kind star to star to star. And if bar is of kind star to star, then foo bar is of kind star. So you apply it like this, and I'm running out of time, but next tutorial we'll go over some of this more. Try and mull over the kind system while you're at it, though. It's important. Anyway, see you next tutorial, and happy Haskelling.